Hello, and welcome to the last section of Statistics Mana 3305. We are now in a downward slope. We finished our first two exams and we're headed to the finish, and what we have left is inferential statistics. So we have finished basic statistics and descriptive statistics. We finished drawing pictures with data, and now we're going to move forward using the information that we know primarily about the normal curve, and we will take that information forward and make informed decisions using that information. The first thing I want to remind you, before I get started, I want to say thank you for resubmitting. Thank you for resubmitting your test answers, and I'm looking at those. I will be assigning credit momentarily where that is needed. And this is all a process. It's all a process to get to where we want to go, and where we want to go is to learn statistics. But what I most want to teach you about is how to be curious. Okay? I don't do video lectures so that it just takes away reading. I do it because I feel like this is my best way to communicate with you. I really feel like I would be cheating you if I just wrote out a statistics lecture. If you feel that written word is more important, the book is always a supplement, and you can reread the book again and again to pick up what you don't get from me. I'm not able to cover every section that's covered in the book. Many people have expressed to me rewatching my lectures helps. If you really want to learn, after you take a test, go back and watch the lectures and see what places you missed or what places you failed to grasp, and communicate that with me via email. Let me know, hey, can you touch a little bit more about this, or I'd like to learn a little bit more about this. Curiosity, that's the key to success in my class. And I just trying to teach you all to be curious and curious about statistics, but soon you'll be taking and moving forward in your degree plan. And I hope that your curiosity in statistics will carry forward and make you successful throughout your academic career. But the information that we've learned in the first 6 chapters, we are going to take and move forward today. We're going to move forward with that information and use it to make informed decisions. Now, the normal curve, we know, looks like a bell-shaped curve. This bell-shaped curve represents 100%. Now, do not forget that this extends forever in both directions. It's centered at the mean, whatever the mean may be. Each problem, it differs. It's centered at the mean, and it's spread out and we measure its spread with tools called variance and standard deviation. Also range, interquartile range, Q1, Q3. These are measures of spread, but the one we will focus on from here on out is the standard deviation. And you should know that 99.7% of my population, I expect to be within 3 standard deviations. What I can do I can talk about a standard normal, because that's easy. A standard normal has a mean of 0 and a standard deviation of 1, so we count this way: 1, 2, 3, minus 1, minus 2, and minus 3. Okay? A standard normal also matches up with the table in the back of your book. Okay? We call the numbers on the x-axis, we call these z. And we learned a formula last time that to be able to find any z. Okay? Any z. A z is just where your observation lies on the x-axis for a standard normal. And again, this Z would be x minus mu over the standard deviation. Okay? Where your observation lies in reference to the mean, where your score is, how much you weigh according to the global average, what the temperature is right now compared to the average temperature for today, the last 100 years. Wherever your observation is, we put it in reference to the mean. Okay? So we compare the distance away from the mean, no matter positive or negative, and divide by how far our curve is spread out. That will give us the percent of observations that we are greater than, or bigger than, or hotter than, or heavier than, or taller than, or smarter than, or more efficient than, so on and so forth. Okay? So it will tell us the probability that that we are taller than someone. It will also tell us the percent of people that are taller than us, that are heavier than us, that are smarter than us, more efficient than us. The percent of days that are warmer than today. Okay? Now, this information is useful, and in the standardized tests, again, it's useful so we know our percentile. For instance, if someone took the ACT, the standardized test to get into college, has a mean of 18, standard deviation of 6. Okay? So for instance, the curve for the ACT would look like this. 18, 24, 30, 36. And that's the maximum score you can score on an ACT. Again, 12, 6, and 0. And notice, our range is 0 to 36. So this actually, in this situation, represents all of our observations, because you cannot get higher than the maximum, you cannot get lower than the minimum. So, if a person scored 18, this is easy. What percent would they have scored greater than? Right, they would have scored more than, or greater than, 50% of the population. I'm going to shade it like this. I shade the curve. Okay, and again, this is review. If a person scored a 24, we know this bar here represents 34% of our population. So 50 plus 34 is 84% of the. You did better than 84% of the people if you scored a 24. If you scored a 30, let's work that one out. So what would your z-score be? Well, we know that your z-score would be 2. Let's confirm that. 30 minus 18 divided by 6 is 12 over 6, which is 2. If I wanted to look that up in the back of the book and find the probability that x, probability less than x, excuse me, as I had it backwards there for a second, it would be, I would be looking up this probability. So I want to know the probability that someone would score less than a 30. Now notice my shading. My shading encompasses quite a bit of the curve. So first, mental check. If it came back and I said 30% chance you would score less than a 30 if everything was random. Well, no. No, that would not be the case, because notice 30% does not make sense intuitively. Intuitively, we can see that this is much more than 50%. We can see that it's much more than 80%. So let's look 2 up in the back of the book, and I encourage you to do that with me. So turn to the table, E2, on page 793, and we can see that 0.9972 or 97.72% probability that if I would randomly select one person, there's a 97% chance that they would have a ACT score less than 30. Now, our class